Hello students, so let's try to solve one more problem from CSIR NET examination, and this exam was held in September 2022, and this problem is from quantum mechanics, and this is very fundamental problem. So in this problem, the wave function, the four wave functions are given, and it is said that the average value of momentum is 0. So we have to choose which particular wave function have average value of momentum is going to 0. And obviously, you can solve this problem in n number of ways. You can just take the momentum operator and find the average value of this for each and every wave function. So this is one way to do this thing, but I am just doing this problem in a very different way. I am just trying to connect momentum with the probability current density. So you all know that probability current density Jx is equal to h cut upon 2im, and we have psi star del psi upon del x minus psi del psi star upon del x, and which will be equivalent to your expectation value of momentum and your probability density. And your probability density is that mod psi square, and this is something like, and you can write this thing as something velocity of a particle. And if you are talking about velocity of a particle, this is nothing expectation value of momentum into mod psi square. So if current density is going to 0, then obviously the average value of momentum is going to 0. So how we can choose what will be the particular average value of momentum is when average value of momentum is 0? So we can directly calculate what will be my current density, which is very easy to calculate. You can just see the first option, and on the basis you can just calculate all other possibility. In the first option, you can see this can be written as suppose this is my psi 1x. This is proportional to e to the power ikx minus e to the power minus ikx. So you can see the same amount of current going towards right and same amount of current going towards left, because this has exactly same amplitude of this one, and negative sign have not any significance because we are just talking about the superposition. So the +1 and -1 is the coefficient, which will not do anything. Just you can see it has the associate. You can also understand that e to the power ikx is the eigenstate of momentum, which has associated momentum as h cut k, and e to the power minus I h cut is also eigenstate of momentum, and that will be minus h cut k. So here you can see that same amount of momentum is coming and same amount of momentum is going outward in opposite direction. So why I am just taking about same amount of current in right hand direction and same amount of current in going towards left direction. So in this particular option, the current density is equal to 0. So if current density is equal to 0, then obviously the momentum must be 0. So obviously option 1 is correct. So momentum is equal to 0. You can analyze all other thing. If you will calculate the current density, this will just behave like as a amplitude, or you can just write in a superposition of eigenstate of momentum. So this can be written as psi 2, and this will be e to the power ikx, e to the power ikx minus e to the power minus ikx, and you can see this can be multiplied with this one. So e to the power 2 ikx minus 1. So you can see that there is only incoming momentum is there, and which has magnitude of 2 h cut k kind of thing. So yes, in this particular thing, the current density is not equal to 0. And similarly, in this case also, you can see e to the power 2i, you can ikx, and I have e to the power ikx and plus e to the power minus ikx. So again, it has 2 ikx plus 1. So you can see again, this is incoming momentum is more than in opposite direction. In opposite direction, there is not any momentum is going on. So this is just coming here. And if you will just try to calculate the average, the current density, you can easily get the current density as h cut k, and that value is equal to sine square kx. So something like of this particular thing, current density you will find. So if you have this sort of current density, so obviously the momentum is not going to zero. So in this case, momentum is not going to zero. Similarly, in this case, expectation value of momentum is not going to zero. And if we will go for the fourth option, this will be superposition of this wave function and superposition of third one. Obviously, this wave function have zero momentum, but it will contribute. This wave function have zero current density, but it will have some current density, some probability current density. So why in this case also Jx is equal to not zero. So expectation value of momentum is not equal to zero. So only option one, sine kx, have current density is zero, as well as its momentum is also, expectation value of momentum is also zero, because it is superposition of two state. One is incoming, another is outgoing. And similarly, here is also there, but obviously there is some different amount of incoming current and some different amount of outgoing current is there. So why there is effective current density, and that will tell you there is momentum. The expectation value of momentum cannot be equal to zero. So I will suggest you just try to use this formula and figure it out what will be the current density in each and every case, and then you can find, yes, they are directly connected to the momentum. The current density is connected to the momentum. So try to do this question again and think very carefully, because it's a very interesting thing that how continuity equation will work to understand the momentum, to understand the probability current density, as well as the charge or charge density or probability density. So whatever we have into electromagnetic theory as a charge density, here we can just analogically compare it with the probability current density. So just try to do this problem with yourself. Thank you.